This section is going to cover the triangle inequality and how we compare sides and angles relative to size. So I think these two properties are probably the two easiest things that we went over in all the year in geometry, and it's something that everybody should get easy points on. So it doesn't take that much effort to learn it, and hopefully we'll get all these right. Just to have a quick review on it right now. So remember, in order to see if a triangle exists, the two smallest sides, whenever you add up the two smallest, so the sum of the two smallest sides has to be greater than the larger side. I should say largest side. So if the sum of the two smaller sides is greater than the largest side, it's a triangle. If it's not, then it's not a triangle. So to determine the third side, we have to subtract the two sides and add the other two sides. So we'll do some examples. I think it'll be easier to see that way. And we're going to do some examples comparing sides and angles. So number one says, which of the following would not be possible for a triangle to have sides with the given lengths? So for letter A, we add up the two smallest, and we ask, is it bigger than 9? Yes. 4 plus 6 is 10. It's bigger than 9. It forms a triangle. Letter B, the same thing. We add up the two smallest sides, and it's greater than 8. Again, we have 10 greater than 8. Sorry, that was letter C. Letter B will actually be the correct answer. Is 2 plus 5 greater than 8? No, it is not. So that's how we figure out if a triangle exists or not. We add the two smallest sides, and we have to see if they're bigger than the third. So because it's running into problem 2, I'm going to erase it. And problem 2 says list the sides of each triangle in order from largest to smallest. Because this right here is a linear pair, I know they have to be supplementary. So this has to be 45 degrees. 45 plus 135 equals 180. And again, I know that the angles inside the triangle have to add up to 180, so it has to be 75. So I have to order them from largest to smallest. So what we do is we take the largest angle, 75. So XZ is our largest. Then 60, XY, that's that side. And then 40, we have YZ. So I just wrote a lot on this. Hopefully it'll make more sense whenever you take a look at your paper and follow along. So XZ, YX, and XZ, or sorry, XZ, XY, and YZ is letter A. So number 3, we're asked to list the angles in order from largest to smallest. Well, I'm not given all 3 sides. Remember, the largest angle is across from the largest side. But I know 105 has to be my biggest angle. So angle E has to be the first one because I'm listing them largest to smallest. And then the next largest angle has to be across from the larger side. So it has to be E, C, and then D. That's going to be letter D. Number 4 says which segment is the shortest? Again, knowing that it has to equal 180 degrees, we have 90 here. The shortest angle is 40 degrees. Across from 40 degrees, we have segment RS. So the answer for number 4 is B. Let's move on to page 23. A landscape architect is designing a triangular deck. She wants to place benches in the 2 largest corners. In which corners should she place the benches? This is a little bit hard to read. So we have 27, 21, and 18. So what are the 2 largest corners? So 27 is the largest number, we have C. 21 is the next largest, we have B. So that would be corners B and C. Number 6 says Jill is building a triangular garden. She has 2 timbers measuring 8.6 feet and 4.4 feet. What is the range of possible values for the third timber? So again, to find the range of a third side, we subtract, and then we add them. Whenever we do that, we get 4.2 and 13, which is D. So that's how we find the range of the third side. Question 7, we're given a graph, so let's use it. It says Q has coordinates 0, 0. R is 7, 0. So there's 7. And S, that's 10 up. So 0, 10. So my side lengths here, QR is 7, QS is 10, and I have a 90-degree angle there. So I'm supposed to list the angles from least to greatest. Well, I know angle Q is going to be my biggest one because it's 90 degrees. The smallest angle is going to be angle S, as it's across from the smallest side, and we have angle R going to be our middle one. So across from 10, our middle side is R. For number 8, we need to find the range again, just like we did in number 6. We're told that Gloucester is 18 miles from Newport News. I'm skipping ahead. Newport News is 12 miles from Williamsburg. Gloucester is 18 miles from Newport News. What is a possible distance from Williamsburg to Gloucester? So all we do is subtract the two values, and we add the two values to find the upper range. So which number here is between 6 and 30? 2 is too small, 10 works, 30 is too big. So remember, it has to be smaller than 30. 35 is too big. So even though 30 doesn't work, 29.99999, that would work.